Hello student, today we are going to start second shifting theorem. This statement is the if Laplace of f of t equal to phi of s and g of t equal to f of t minus a when t is greater than a and g of t equal to 0 when t is less than a, then prove that Laplace of g of t equal to e raised to minus as phi of s. So this theorem is belong to the unit step functions. So it is a use in the unit step functions. Now see the proof of this theorem. So by definition of Laplace transform, as you know that the definition of Laplace transform, L of g of t equal to integral of 0 to infinity e raised to minus st g of t dt. So this integral 0 to infinity is divided in the two parts. One is 0 to a and second is a to infinity. Because the function of range is given here, g of t equal to f of t minus a is t greater than a and g of t equal to 0, so t is less than a. So this 0 to infinity is divided in the two parts. So first part I have taken the integral 0 to a e raised to minus st g of t dt plus second integral is a to infinity. So integral of a to infinity e raised to minus st g of t dt. So the range of 0 to a g of t is given here 0. So substitute over here and plus second integral range integral of a to infinity e raised to minus st and g of t is given f of t minus a. So first will be the 0, it will multiply with 0 into e raised to minus st. Now we'll get only the second integral a to infinity e raised to minus st f of t minus a dt. So try to bring in the form of this integral will be 0 to infinity. So now see how to solve it. First of all, change all these variables. So put t minus a equal to p. Now differentiating with respect to p. So dt equal to dp. Now they change the integrals value also. So put when t is a, so a minus a minus a is 0. So p will get the 0 and the second put t as a infinity. So t infinity minus a is infinity. So second value p will get the infinity. So your new integral will be 0 to infinity. Instead of a write on 0, instead of infinity you can put it infinity. And it will be changed over here also, e raised to minus s and t write down transfer over here. So t equal to a plus p. So here write down a plus p and f of t minus a is equal to p. So f of p dp. Now this exponential part we have to solve by the law of indices. So e raised to minus sa into e raised to minus sp. So e raised to minus s you have to take outside of the integral and then integral of 0 to infinity e raised to minus sp f of p dp equal to e raised to minus as integral of a to infinity e raised to minus st f of t dt. So by change the variable of integration, apply the form change of variable of integrations. Instead of p write down the t. So this is a look like as a definition of Laplace transform. So Laplace transform definition of Laplace transform is L of f of t. So this equal to e raised to minus as L f of t and L f of t here taken the function L of t equal to phi of s. So this proof is over. Now I've taken some example of based on these theorems. So Using second shifting theorem, first example is Laplace of f of t, where f of t equal to cos t minus alpha, t is greater than alpha, and f of t equal to 0, t is less than alpha. So this problem also solved by using the second shifting theorem, or easily we can solve. First of all, take the function. So here function is given cos t. So first of all, find the Laplace of cos t. So we know that the definition of Laplace t is a Laplace of cos t equal to s upon s square plus 1, and this function I have taken as a phi of s. So by definition of second theorem is Laplace of cos t minus alpha equal to e raised to minus alpha s into this phi of s. So the phi of s is s upon s square plus 1. And second example is given here, L f of t, where f of t equal to e raised to t minus k, t is greater than k, and f of t equal to 0, t is less than k. So again, first of all, find the Laplace of e raised to t. So we know that the Laplace of e raised to t equal to 1 upon s minus a, that is the function I have taken phi of s. Hence by second shifting theorem, Laplace of e raised to t minus k equal to e raised to minus k into phi of s, and phi of s is given here 1 upon s minus 1. So these are the example based on the second shifting theorems. I hope all of you will be understood. Thanks for watching the video.